we have to evaluate the integral 0 to 1 x over x positive 1 times x positive 2 dx. Okay, so to make the integration process easier for this rational function, what I'm going to do is I'm going to write this rational function into partial fractions. So x over x positive 1 times x positive 2, which is equal to here, to write the given rational function into partial fractions, I have to look at the denominator. Here, the denominator is a product of two binomials. When you look at the first binomial, the exponent of the variable x is 1. The exponent of the binomial is also 1. So we get a over x positive 1 for the first binomial in denominator. The second binomial also have the same thing, that is the exponent of the variable x is 1, the exponent of the binomial is also 1, so I get b over x positive 2. Okay, now my aim is to get the values of a and b. So the aim of writing the given rational function into partial fractions is we can split up the rational function into fractions so that we can integrate the given function easily. That's the aim behind writing the given rational function into partial fractions. Okay, now I have to get the values of these two unknown constants a and b. For that, I'm going to do cross multiplication over here. That is, I'm going to multiply this a by x plus 2 and this b by x plus 1. Finally, I multiply the two denominators x plus 1 and x plus 2. Okay, so we have x over x positive 1 times x positive 2. So I multiply this a by x plus 2. So I get a times x positive 2 positive b times x positive 1. So I have to multiply the two denominators. So I get x positive 1 and x positive 2. Okay, here on the right side, on the left side, we have the same denominator, x positive 1 times x positive 2. So we can cancel out. So I get x is equal to a times x positive 2 positive b times x positive 1. Okay, I've already told you that my aim is to get the values of these two unknown constants a and b. Okay, to get the value of b, I have to plug in some value for x so that a will vanish. So if we plug in x is equal to negative 2, so negative 2, positive 2, this part will become 0. So finally a will become 0. So a will vanish. I'll be getting the value of b. If I plug in x is equal to negative 1, so this part will completely become 0. So b will vanish. I'll be getting the value of a. Okay, now what I'm going to do is first, let me plug in x is equal to negative 2. So that a will vanish. So in the complete equation, I have to plug in the complete equation. I have to plug in x is equal to negative 2. So I get negative 2 is equal to a times negative 2 positive b times negative 2 positive 1. So negative 2 is equal to, so negative 2 positive 2 will become 0. 0 times a is 0. So a will vanish. So b times negative 2 positive 1 will become negative 1. So negative 2 is equal to, so b times negative 1 will become negative b. So my aim is to get the value of b. Here we have negative b. So to make this negative b as positive, so I multiply both sides by negative 1. Then I get 2 is equal to b. So the value of b is 2. Okay, now what I'm going to do is I'm going to plug in x is equal to negative 1 so that b will vanish. So the complete equation, I have to replace x by negative 1. So negative 1 is equal to a times negative 1 positive 2 positive b times negative 1 positive 1. So a times negative 1 positive 2 will become just 1 positive. This will become 0. B times 0 is 0. So negative 1 is equal to a. So I got the values of a and b. A is equal to negative 1 and b is equal to 2. Have to plug in these two values. A is equal to negative 1 and b is equal to 2 over here. Okay, let's do that. Okay, here I'm going to take integration, the given integration on both sides. It is 0 to 1 dx, integral 0 to 1 dx. Okay, here I replace this a by negative 1 and I replace this b by 2. So in the next step, 0 to 1 negative 1 over x positive 1 positive. This rational function can be written as 2 times 1 over x positive 2. Okay, here in this rational expression 1 over x positive 1, if I find the derivative of this x positive 1 with respect to x, what will I get? I'll be getting 1 that we have exactly in numerator. So here in this part, the derivative of this x positive 1 is 1 that exactly we have in numerator. So the integration of such function is ln of what we have in denominator should be taken, that is ln of absolute value of x positive 1. So whenever you have the derivative of the denominator is in numerator, so the integration of such function is ln of what we have in denominator. So here for x positive 1, I am taking absolute value because logarithm is never defined for negative value. So that's why I'm taking absolute value for x positive 1. Even if this, even if the value of x positive 1 is negative, it has to be taken as positive. And we can take this negative sign over here. Okay, here positive 2 times. So the same thing we have over here, that is the derivative of the denominator x positive 2 with respect to x is 1, that we have exactly in numerator. So the integration of this function is ln of what we have in denominator, that is absolute value of x positive 2. Okay, now I'm going to take the limits 0 to 1. Okay, now in the complete result, I have to plug in the upper limit 1 for x. Then we have to take negative sign. Again, for the complete result, I have to plug in the lower limit 0. Okay, first let me plug in the upper limit 1 for x in this result. So let me do it on the next page. Negative ln of absolute value of 1 positive 1 is 2 times ln of 1 positive 2. That is, I replace this x by 1. Now I have to take negative sign for the same result. I have to plug in the lower limit 0 for x, and I'll be getting negative ln of 0 positive 1 positive 2 times ln of 0 positive 2. Here negative ln of, so it's going to be 1 positive 2 is 2. Absolute value of 2 is still 2. Positive 2 times ln of 1 positive 2 is 3. Absolute value of 3 is just 3. Negative. So 0 positive 1 is just 1. Absolute value of 1 is just 1. Positive 2 times ln of 2. So here we can remove the bracket, square bracket. So we get negative ln of 2, positive 2 times ln of 3. Negative times negative become positive ln of 1. Negative times positive become negative 2 times ln of 2. So here we can write this term first because we have this one with positive sign. So 2 times ln of 3, and this one are like terms because both the terms contain ln of 2. So when I combine these two, I'll be getting negative 3 ln of 2 positive. The value of ln of 1 is 0. Natural logarithm of 1 is 0. So I get. So the next step, what I'm going to do is I'm going to use the power rule of logarithm. That is, I can take this 2 as exponent of 3, this 3 as exponent of 2. I'm getting ln of 3 square negative ln of 2 to the third power. Okay, so it's going to be ln of 9 negative ln of 8. Okay, here the two logarithms are in subtraction. So I can use the quotient rule of logarithm. So that is whenever two logarithms are in subtraction, so we can divide the arguments. Whenever two natural logarithms are in subtraction, we can take the natural logarithm once and we can divide the arguments 9 and 8. I get 9 over 8. So the evaluation of the given logarithm is natural logarithm of 9 over 8.